everyone, my name is Ying, and today I will presenting my calculus final presentation titled Application of Derivative and Integral in Real Life. Calculus is one of the most important branches of mathematics because it helps us understanding how things change and how quantities accumulate over time. Although many people think calculus only exists in textbook, and it's actually used in many aspects of our daily life, such as transportation, engineering, business, medicine, and technology. In this presentation, I will explain the concept of derivative and integral, together with several real-life applications, and show why calculus is so important. Calculus is the branch of mathematics that studies continuous change and accumulation. It allows us to analyze situations where quantities are constantly changing over time. Calculus consists of two main branches, namely derivative and integral. A derivative measures the rate of change of quantity. In a simple word, it tells us how quickly something changes at a particular moment. For example, when we want to know how the speed of moving car at a specific time, we use derivative. On the other hand, an integral measures accumulated quantities. Instead of looking at how something changes, it calculates the total amount of accumulation over an interval. For example, it can be used to calculate the total distance traveled by a vehicle by the area under the graph. Therefore, the main objective of this presentation is to explain these two important concepts and demonstrate how they apply in the real-life problem. Let's begin with derivative. A derivative measures how fast a quantity changes with respect to another quantity. In mathematically, we usually write it as dy over ds, which respects the rate of change of y with respect to s. Another way to understand derivative is by thinking about the slope of a curve. If a graph becomes steeper, the value is changing more rapidly. If the graph is flat, the change is very small. Besides measuring the slope of the graph, derivative is also used to predict trend and analyze changing situations. A simple real-life example is driving. As a car moves, the position changes continuously. By taking the derivative of distance and with respect to the time, we obtain the car instantaneous speed. Another important characteristic of derivatives is that they help us to understand whether a function is increasing or decreasing. If the derivative is positive, it means the function is increasing. If a derivative is negative, then the function is decreasing. When the derivative is equal to 0, it's often indicating a turning point, which may represent a maximum or minimum value. This concept is especially useful in optimization problems where we need to find the best possible solution. One of the most common applications of derivative is in driving. As a vehicle moves, its distance changes continuously over time. By differentiating the distance function, we obtain the velocity, which tells us how fast the vehicle is traveling. If we differentiate velocity again, we obtain acceleration. Acceleration tells us how quickly the speed itself is changing. This information is extremely useful in modern vehicles. For example, speedometer continuously display the vehicle speed. GPS system estimate the traveling time based on speed, and cruise control automatically adjust the vehicle speed. Another important example is the anti-lock braking system, or ABS. During emergency braking, this system monitors changing in speed and acceleration to help prevent the valve from locking, making driving safer. Therefore, derivatives play an important role in transportation and road safety. Another important application of derivative is business optimization. Every business wants to maximize profit while minimizing production costs. However, producing too many products can increase waste, while producing too few can reduce sales. Using derivative, business can determine the production level that gives the maximum profit. Mathematically, this occurs when the first derivative of the profit function equal to 0. For example, imagine a bakery producing cakes every morning. If the bakery produces too many cakes, some may remain unsold. On the other hand, producing too few cakes means losing potential customers. By applying derivative, the bakery can determine the optimal number of cakes to produce, increasing profit while reducing unnecessary costs. Imagine a bakery that sells chocolate cakes every morning. If the bakery prepares only 80 cakes, but the customer demand is 120 cakes, many customers will leave without buying anything, result in lost sales and lower profit. However, if the bakery prepares 180 cakes but only sells 120, the remaining cakes may be unsold, leading to waste ingredients and higher production costs. By applying derivative, the bakery can determine the production level that maximizes profit while minimizing waste. This allows the owner to use ingredients more efficiently, reduce unnecessary expense, and satisfy customer demand at the same time. Similar optimization techniques are also used by factories, supermarkets, and online business to improve productivity and profitability. From the example we have discussed, we can see that derivatives are useful in many different fields. In physics, derivatives are used to calculate velocity and acceleration. Engineers use derivatives when designing roads and bridges to ensure that slopes are safe and practical. In business and economics, derivatives help companies analyze costs, revenues, and profit to make a better decision. In biology, derivatives are used to study population growth and the spread of diseases. Overall, derivatives help us understand how things change over time, making them an essential tool for solving practical problems in daily life. Let us move to the second branch of calculus, which is integration. Unlike derivative, which measure change, integral measure accumulate quantity. They add together many small values to obtain the one total value. One of the most common interpretations of the integral is the area under the graph. Besides finding area, integration is also widely used to calculate volume, total distance traveled, accumulated cost, and many other quantities. Therefore, whatever we need to find a total amount, integration is often the most suitable mathematical tools. Unlike derivative, which focus on the rate of change at a particular point, integral focus on the total accumulation over an interval. You can think of an integral as adding together infinitely many very small pieces to obtain one complete result. This is why integration is often associated with finding total quantity, such as total distance, total area, total volume, or accumulated cost. Because of the ability, integrals are widely used in many scientific and engineering applications. A common application of integration is calculating distance from velocity. If a vehicle travels a constant speed, we can simply multiply speed by time to obtain distance. However, in reality, vehicles rarely move at a constant speed. They speed up, slow down, stop at traffic light, and encounter traffic congestion. In many situations, integration allows us to calculate the exactly total distance traveled by adding together at the small change of velocity over time. This principle is widely used in GPS navigation system, aircraft navigation, and vehicle tracking technology. A person driving from Kuala Lumpur to Johor Bahru, during the journey, the driver may travel at 110 km per hour on the highway, slow down to 40 km per hour because of traffic congestion, stop at several traffic lights, and then accelerate again after the route becomes clear. Since the speed is constantly changing, multiplying a single speed by time would not apply an accurate answer. By integrating the velocity over the entire journey, we can calculate the exact total distance traveled. This same principle is also used in GPS navigation system, airline flighting planning, and fitness tracker that record the distance covered during walking, running, or cycling. Another important application of integration can be found in the construction and engineering. Engineers frequently use integration to calculate land area, building volume, and the amount of material required for a construction project. For example, before construct a building, engineers estimate the total volume for concrete need for the foundation and structure. Accumulate calculations helps to reduce material waste, lower construction costs, and improve project planning. Therefore, integrations play an essential role in ensuring the construction projects are both safe and cost-effective. Integration is also very important in statistics, especially when dealing with continuously probability distribution. For continuously random variable, probability is represented by the area under a probability density curve. The total area under the curve is always equal to 1, represent all possible outcomes. This concept is widely used in medical research, artificial intelligence (AI), weather forecasting, and manufacturing quantity control to make predictions and analyze data. For example, hospitals use probability distribution to estimate the effectiveness of new medicine and the likelihood of patients recovering after treatment. Weather forecasting agencies also use probability models to predict the chance of rainfall or storm. In artificial intelligence, recommendation systems on platforms such as Netflix and YouTube analyze probability to suggest movies and videos that users are most likely to enjoy. This calculation also rely on integration because the probability of continuous random variables is represented by area under the probability density curve. Before ending the presentation, let us compare derivative and integrals. A derivative focuses on measuring the rate of change of quantity. It is commonly used to determine slope of the graph, calculate velocity and acceleration, and solve optimizing problems such as maximize profit or minimizing costs. In contrast, an integral focuses on accumulate quantity. It is used to calculate area under the graph, determine total distance traveled, calculate volume, and find probability for continuously random variable. Although their purposes are different, both concepts complement each other and are equally important in solving practical problems. In conclusion, derivatives and integrals are two fundamental concepts in calculus that has numerous applications in our daily life. Derivatives help us understand how quickly quantity change, while integral help us calculate accumulated quantities over time. Throughout this presentation, we have seen how these concepts are applied in transportation, business, engineering, construction, and statistics. This example clearly demonstrates that calculus is more than mathematical subject taught in a classroom. It is a powerful tool that helps us solve real-world problems, improve efficiencies, and make better decisions in many different fields. And thank you very much.